Hi, welcome to Chapter 15, Probability Distribution. We came across probability last year, and in this chapter, we are going to dig into probability a bit deeper, and it will help a lot if you guys still remember the probability stuff that we learned, okay? Don't forget to download the PDF for Chapter 15 from the class website. To begin with, let's see what does it mean by random. Okay, so if you hear someone says we randomly picked the restaurant for dinner last night, did they really choose the restaurant randomly, or did they actually there is some sort of bias involved in the decision making process? Okay. So when we talk about random in math, especially in statistics, we are talking about something that happens because of chance. If you roll a dice, you will get some number, and that number is an outcome that happens because of chance. Right? I get a 3 this time. It has nothing to do with the next time I roll the dice. So it is all by chance. Now, we human beings like to come up with a pattern to describe the randomness of such random event. Right? So how do we describe randomness? We are going to use this thing that's called probability distribution. Please write down this term. I will be explaining what probability distribution is in the next video. But for now, in this video, I want you guys to know what does it mean by random, and the next term will be random variable. Okay, so we have quite a number of key terms. Make sure you write them down. Alright, so random variable. We came across variable many times already, and the alphabets that we use for variable most of the time is X or Y. Now, when we talk about random variable, a random variable is the result of a chance event that you can measure or count. So, a random variable is sort of like the probability of something to happen, but that something that could happen because of chance must be measurable or countable. Okay? So we have two elements here. The first one, it must be a chance. The second part, it has to be measurable or countable. Alright, please write that down. If you're still confused with the definition, I have a few examples here. Okay, the first one, a very typical textbook example would be tossing a coin. So in this case, I'm going to flip the coin 2 times, and I'm going to record down my outcomes. Right? So I could get head and head, I could get head and tail, I could get tail and head, and I could also get tail and tail. These are the 4 possible outcomes, and they happen. This combination happens due to chance, right? Due to chance. So now, here's the highlight. X, I'm going to use X, which is a variable. That X is going to represent the number of heads. The number of heads. Okay, the X represents the number of heads. Just now we already said that all these possible outcomes, they happen by chance. And X represents the number of heads, which means I can count. Here I have 2 heads. Here I have 1 head. Here I have 1 head. Here I have 0 head. So my X can take on the values of 0, 1, or 2. And in fact, my X is a random variable because we can count it. 0, 1, right? 2. And also, these outcomes happen by chance. Most of the time, students get confused with the values here. I'm my x represent the number of heads. I have 2 heads. That's why I get the 2. 1 head, I get a 1. Another 1 head, I don't have to write that down, right? No heads, 0. So my x, we need to be, you guys need to be sure that what does the random variable represent. Very, very important, okay? Another example, a less typical math textbook example. So let's say today you have, you open an ice cream store, and these are the possible random variables that we could find. So the first one would be the number of male or female customers. We can count how many males, we can count how many females, and also the gender of the customers that come into your ice cream shop. We cannot decide if it's a male or female because that happens by chance. But that is a random variable. Another one could be the number of customers who paid by cash. Right? So here we can count them, and also we cannot really whether the customers pay by cash or not, or credit card or vouchers. It happens by chance, but it can be countable, and it also happens by chance. So we have a random variable. The last one could be the number of broken cones. So sometimes when you are trying to get your ice cream ready for your customers, the cones might break, right? And you can count them. You can count 1 broken cones, 2 broken cones, whatever. And also, it's not sometimes whether the cones break or not. It's not really. It happens by chance as well. So all of these are examples of random variables. Now, not random variable. So flavors of ice cream. You will say chocolate, vanilla, strawberry, whatever. You cannot count them, right? The responses to this would be the flavors that I mentioned. Right? So you cannot count them. The second one, the ethnicity of customers. So the ethnicity could be Asian, it could be Caucasian, it could be Spanish, whatever, right? So again, you cannot count them. The last one, method of payment. It can be cash, it can be credit card, it can be voucher. So again, not countable. So these are some examples of not random variables. I hope you guys see the difference between random variables and not random variables. It always comes back to these 2 components, chance and measurable, countable. Okay? So, in the next video, I'm going to show you guys what are the different types of random variables. But for now, this is it. Make sure you take down some notes, and I'll see you guys in the next video. Bye bye.